Hey guys, this is the conceptual piece for 4.3 and what we're trying to work with here. And we're working with equations in standard form, our quadratics, which means they look like this: y equals ax squared plus bx plus c. Now, there's going to be some special cases where, a is, in this first assignment, we're going to be looking at cases where a always equals 1. That's going to make the problems a lot easier for us here in 4.3. 4.4 will definitely take a little bit more of a challenge, but we're going to be working with that. Now, if you've ever done what's called a diamond problem, this is actually going to be pretty familiar to you. If you think of having x and y here, two numbers, up here you add them, so you get x plus y, and then down here you multiply them, you get x times y. Okay. This concept is really, you've used it probably for a few years, and it's something that was building towards this concept of factoring, which is what we're really working on here today. And the premise is trying to get this into factored form so it looks more like x minus p times x minus q. Okay? Where p and q are the points where I cross the x-axis. There'd be P, there'd be Q, and there's my parabola crossing through P and Q. We really love finding these points because they have significant value as values when the equation equals 0. Those are really truly what we're after, and in order to do that we need to be able to understand factoring. Now this diamond pattern, it really has a lot to do with that. Let me give you an example. Let's say that I have the numbers, let's say I have a 12 here and maybe a 7 here. Okay, so I know my two numbers, when I add them I'm getting 7, and when I multiply them I'm getting 12. So what two numbers work to do that? And it turns out that I can use a 3 and a 4. I add them, I get 7, I multiply them, I get the 12. If I do another one of these, maybe I have a negative 5 here. So that means when I add these two numbers I get negative 5. But when I multiply them I get negative 14. So I'm thinking, what multiplies to make 14? Well, the first things that come to mind are 2 and 7. Well, if I allow one of them to be negative and the other to be positive, that will account for that negative in front of the 14. So I know I've got a 2 and a 7. They are 5 apart from each other, but in order to get a negative 5 up here, I really need the 7 to be negative. And so this concept of the diamond problems is really something we can use and utilize as we go to factor. For instance, if I gave you the problem x squared minus 14x, no, I did that backwards. Sorry, minus 5x minus 14. And I wanted to factor this. I could use this concept of, how do you divide a 14 up? Be 1 and 14 or 2 and 7. Now I want to be able to, this is really important, because the 14 is negative, I want to subtract them. One of them's got to be positive, one of them's got to be negative, and I somehow have to get a negative 5. If I use a negative 7 and a positive 2, they will multiply to my negative 14. But when I combine them by addition, I'll still get a negative 5. That means that the factored version of this original problem is x plus 2 times x minus 7. Now, if you aren't totally convinced, what we can do is we can actually FOIL these two parentheses together. An x times an x is x squared. An x times a negative 7 is negative 7x. A 2 times an x is a positive 2x. And a 2 times a negative 7 is a negative 14. Combining our like terms, we end up with x squared minus 5x minus 14. So we can see how this diamond problem sort of introduced the idea of finding factors, finding specific factors. So in your homework today, it's all about going from this standard form to this vertex form. And one of the big payoffs of having the vertex form, if the equation is y equals x plus 2 times x minus 7, and we want to know what are the zeros of the function or zeros of the equation, that literally means to put a 0 in for y and ask the question, when does this equal 0? Well, the good news is we already have a shortcut for this. Instead of saying, well, what number would make that 0 and what number would make, I'm trying to get 0 for this parentheses or 0 for this parentheses, because we know that if one of the parentheses, let's take this left one, let's say that it becomes a 0. Well, that 0 times anything in the other parentheses is still going to be 0, and vice versa if it's the second parentheses. So that being said, what number for x, when I add 2, is going to produce a 0? X would equal -2 and +7. We know these are our two values just by saying we're going to switch the sign. We're going to reverse the sign as we pull these numbers out. Okay? We pull out the 2, it becomes negative. Pull out the 7, it becomes positive. And we're good. This is what we're really after. We need to know these zeros or values that make the equation equal to 0. Good luck, guys. We'll see you in class, and come with your questions.